The world is full of questions. Why do people buy certain products? How can we predict customer behavior? Why do people act the way they do in social situations? Scientists, marketers, and researchers use a tool called the scientific method to find answers. The scientific method is one of the best ways to find out how and why the world works. It helps us discover truths without letting personal beliefs, politics, or religion interfere. This method guides us to ask questions, make predictions, test them, and learn from results in a fair and unbiased way. It's important to know 3 key terms. 1. Hypothesis. A hypothesis is like a working guess that a researcher makes about something. It is a statement that can be tested to see if it is true or false. The purpose of a hypothesis is to guide research and experiments. Think of it as a prediction based on what you already know. For example, offering discounts will increase online sales. Here, the researcher guesses that giving a discount will make more people buy a product. 2. Theory. A theory is a bigger idea that explains patterns we see in the world. It comes from testing many hypotheses and finding consistent results. A theory helps predict what might happen in the future based on past evidence. For example, cognitive dissonance theory explains why people feel uncomfortable when their actions do not match their beliefs, like when someone knows smoking is bad but continues to smoke. Theories are broader than hypotheses. While a hypothesis is a single guess, a theory explains many observations and can guide future research. 3. Falsifiable or null hypothesis. For a hypothesis to be scientific, it must be falsifiable, which means it can be proven wrong. Scientists often try to disprove a hypothesis to make sure it is reliable. The opposite of the hypothesis is called the null hypothesis. For example, hypothesis: offering discounts increases online sales. Null hypothesis: offering discounts does not increase online sales. Steps of the scientific method. 1. Define a question. The first step is to ask a clear question. A good question is testable and measurable. Testable means you can design a way to check whether it is true or false. For example, you cannot test, is chocolate the best food in the world? Because it depends on personal opinion. But you can test, does offering a free sample increase the number of people buying a product? Because you can measure the number of buyers. Measurable means you can count, record, or observe it. In our example, the measurable part is the number of people buying after receiving a sample. What to do? Write the question clearly in one sentence. Focus on one main thing you want to study. Make sure it can be answered with an experiment. Tools and resources. ChatGPT can help you refine your question. For example, you can ask, help me turn my idea into a testable research question about sales. 2. Gather information and resources. Before testing, collect all available information about your topic. This is called a literature review. Understand what is already known and avoid repeating what others have done. Read about key facts and theories related to your question, previous experiments or studies, gaps in knowledge you can explore. What to do? Search online articles, reports, journals, or books. Take notes and organize the information in a table or document. Identify patterns or ideas that help design your experiment. Tools and resources. Use Google Scholar, research databases, or online libraries. ChatGPT can help summarize articles or give lists of scholarly sources. Ask, give me 5 Google Scholar articles about factors that increase product sales. 3. Form a hypothesis. A hypothesis is a clear, testable prediction of what you think will happen. It has variables: independent variable, the thing you will change like giving a free sample; dependent variable, the thing you will measure like number of people buying the product; controlled variables, things you keep the same to make the test fair like same store, same day. What to do? Write a short statement. If I change this, then this will happen. Make it specific and measurable. Make a null hypothesis, which is the opposite statement to test if your prediction can be proven false. Example, hypothesis: if free samples are given, product purchases will increase. Null hypothesis: free samples will not change product purchases. 4. Plan and perform the experiment. This step is about testing your hypothesis. Design. Create a detailed procedure. Include step-by-step instructions so anyone can repeat it. Manipulate variables. Change only the independent variable, the thing you want to test. Keep all other factors the same so the test stays fair. Collect data, record results carefully, using numbers, charts, or notes. What to do? Decide how many trials or observations you need to make results reliable. Prepare tools or materials. Follow the procedure exactly. If your hypothesis is that giving a free sample increases product interest, your independent variable is the free sample. Your dependent variable is how many people show interest. You would prepare a plan, give the sample, observe the response, record the number, and repeat it several times under the same conditions. 5. Analyze the data. After collecting data, check if your hypothesis is correct. Look for patterns. Compare results from different trials. Use calculations. Find averages, percentages, or other measurements. Visualize results. Make charts, graphs, or tables to see trends clearly. What to do? Ask, does the data support your hypothesis or the null hypothesis? Explain what the data shows in simple words. Note any unexpected results. Tools and resources: Excel, Google Sheets, or data visualization tools. ChatGPT can help interpret the data or suggest ways to visualize it. 6. Report the results. Share your findings in a clear and organized way. Elements to include: question and hypothesis, materials and procedure, data and analysis, conclusion, what you learned, what to do, write a report, create a presentation, or record a video explaining each step. Include charts, tables, or images to make it easy to understand. 7. Retest the hypothesis. Finally, repeat the experiment to make sure your results are reliable. Why? Sometimes results can happen by chance, so testing again confirms the truth. How? Repeat the same steps or test under slightly different conditions. Outcome: reliable results strengthen confidence in your conclusion.